Hello, Legacy Savers. Marsh here. So today we're going to talk about graphing parabolas in focused directrix form at the origin. Again, you're going to want your conics foldable, and then pen or pencil. You might want some other colors today, but not as much as the last couple of conics that we've been discussing. So first, what is a parabola in the conic sections? Well, parabola is just a conic section in which any point of the parabola is equidistant from a fixed point called the focus and a fixed line called the directrix. You don't need to write that information down. However, we do need to identify some pieces on this graph or this diagram. First of all, we have the vertex. The vertex is what the parabola will go through. Then we have the focus. Again, the focus is a dot that's in the middle of the parabola, kind of like the hyperbolas kind of had that. And then we have what's known as the directrix. The directrix is a line behind the parabola. And then we also have what's known as the axis of symmetry. The axis of symmetry we identified when we did parabolas earlier. They are basically just a line that is the perfect folding point for the parabola. Now, what we know is that any line that is from the focus to the parabola is also equidistant from the directrix. So I can draw a line here. This line would be equivalent to this line. Now, I know it doesn't look like that, but that is because of the terrible drawing. We are going to be identifying the focus, the directrix, and the axis of symmetry, and the vertex on each and one of our graphs here. The equation of a parabola that is up and down is x minus h quantity squared equals 4 times p y minus k. Now, this p-value is the number of positive or negative units that the vertex is to the focus, and also the vertex is to the directrix. If our p-value is positive, the parabola is going to open up. If the p-value is negative, the parabola will be opening down. Thus, the focus would open down and the directrix would be above. So this p-value is going to be the most important thing for us to find each and every time. When my x is squared, that means you're going to be opening up or down. Now, there does exist left and right looking parabolas. Same pieces, we still have a vertex, we still have a focus, we still have a directrix, and we still have that axis of symmetry. Each of those places or dots or parts of the parabola still exist just like the up and down one. However, they're just kind of turned on our graph. If our graph is left and right, we will notice that the y will be what is squared. So this is a y squared. And again, that p is going to identify how far left and right your vertex is to the focus and your vertex is to the directrix. If my p is positive, the parabola opens to the right. That makes sense because to the right is always a positive number, right? And then the p is negative, the parabola will open to the left of or be opening to the left. So that's the first thing we're always going to identify on a graph is which way is this thing opening, so that way we know which way to draw it and also which way to put a focus and which way to put the directrix. Now, let's make sure we can find that p, because if we can't find the p, we can't basically graph these things. So notice the 4 times p is in front of the y. So that means this negative 12 is equal to 4p. If I divide by 4, we will get negative 3. Since this is an x squared and it's a negative, this parabola would open down. Okay? Let's try it again. 4p is in front of the x, so it's an 8. So I'm going to say 4p equals 8. That means p equals 2. Since it's a y squared and a positive number, we're going to open to the right. And again, 4p equals 6. Now you're like, Marsh, that doesn't simplify. You're right. It's just a kind of an icky fraction. That's okay, though. That would be 3/2. Since this was a y squared and it's positive, again, this guy will open to the right. Here's how I keep this straight, which with who opens to the left and who opens down and all that. X squared is a normal thing. We're used to x squared. X squared is what we consistently have seen when we are graphing parabolas before we started this unit, right? That's how I know that an x squared means up or down. It's something I'm used to. And we only have graphed parabolas that were opening up or opening down the last couple. Y squared is something new. We have never seen a y squared when we've been graphing parabolas. That's how I know that that's a right or a left. That's how I keep them straight in my brain. Let's try the first problem. So first thing I'm going to do is I'm going to find that p-value. So I'm going to take this 8 and set it equal to that 4p. My p-value will be 2. So I'm going to put a 2 there. I'm opening, since it is y squared, that means it's either left or right. My p-value is positive, so this will be opening to the right. Okay? Our vertex today and every day will be 0, 0. Okay? For right now, we will be translating these things, but for right now, every problem today will be 0, 0 for a vertex. So what I'm going to do over here is I'm going to put my dot and put a big giant V by it. And what I'm going to do now to find the focus in the directrix is I'm going to follow my directions. I said 2 to the right. That should give me my focus. So I'm going to go 2 to the right, put my focus there, and then my directrix, I got to go 2 to the left. So I'm going to go up and down. Right there. There we go. So now let's write the equations of those lines that I just drew. The equation of the directrix is x equals, because it's going through the x-axis, -2. So x equals -2. My focus ordered pair dot is 2, 0. So I'm going to write that there. Okay. Now, I need to actually graph this thing, right? I need to find the focal width. Now, the focal width is how wide are you around the focus. Focal width, focus, kind of makes sense, right? The focal width is actually the easiest thing to identify. It's literally this number right here. No difference, just that number. So it's 8. So that means from arm to arm of my parabola, I have to have a distance of 8. Which means from arm to focus, I have to have a distance of 4, right? So I'm going to go 1, 2, 3, 4. 1, 2, 3, 4. And then for my vertex, I can actually draw through those dots. Notice from here to here is a distance of 8. That's why it's called the focal width. You are identifying how wide around the focus is your graph. My axis of symmetry, notice if I drew an imaginary line right here, that would perfectly fold that parabola in half. That is the line y equals 0, because I'm cutting through the y-axis. My domain, the directrix does not count, okay? It's only the parabola that you drew. So my domain started at 0 and went to positive infinity. But my range, I have everything below and everything above. Not terrible. I actually like parabolas. I think they're one of the easier conics. Let's try the second one. I'm going to change my color here. Purple. So first thing, I'm going to take this guy and I'm going to set it equal to my 4p. Divide by 4. I'm going to get p is -5. And now I'm going to take a look. It is an x squared, which means it's either up or down. My p is negative, thus we are opening down. My vertex, again, like I said, today, it'll always be 0, 0 today. Then I'm going to follow my steps. I'm going to go down 5. That negative told us to go down, okay? So don't be going down -5, which means up. Don't do that. Do not do that. follow your directions. You're going down 5. So I'm going to go down 5. 1, 2, 3, 4, 5. That is my focus. Mark this as the vertex there. And I'm going to go up 5 to find my directrix. 1, 2, 3, 4, 5. Right here. There we go. Okay. Let's write that equation, and that ordered pair. So my focus is at the dot, 0, -5. My directrix is at the line, y equals +5. Okay. My focal width will be 20. Now notice I left the negative off. That is because a width cannot be negative. Think about it. A width cannot be negative. That makes sense, right? Widths can't be negative. So around my focus, since it's the focal width, will be 20 from arm to arm. From arm to focus will be 10. So I'm going to go 10 this way, put a dot. 10 this way, put a dot. Now I'm going to graph. Be nice and wide. Nice wide parabola there. There we go. My axis of symmetry, if I drew a line, it would be right here, cutting down the middle. So that would be the equation x equals 0, since I cut through the x-axis. My domain, I have everything to the left and everything to the right. But my range, I did go down to 0. I have everything negative, and then I stopped at 0, but I did hit 0, so there is a bracket on there. And that is the end of this video. Not as many pieces to graphing the focal or the conic section of parabola. Next time we see one another, we will be graphing them when they've been translated or moved around. Until then, though, I will see you later, Sabers.